Students, welcome to Arith. Today we'll go for mechanics. So, mechanics means study of motion. It is divided into three branches. One is statics, second one is kinematics, third one is dynamics. Now, kinematics means study of motion without going for its cause. Dynamics means study of motion with its cause. So, what is the cause of motion? The cause of motion is force and energy. So, we can say if we study a motion with considering force and energy, that is called dynamics. If we study the motion without considering force and energy, that is called kinematics. Now the last part, statics. This is study of rest of a particle which is under action of a large number of forces. That is called statics. So mechanics is divided into three parts: statics, kinematics, dynamics. In statics, we'll study about the rest. In kinematics, we'll study about the motion and without considering the cause of motion. In dynamics, we'll study the motion with its cause, that is with force and energy. Now, we'll go for the kinematics. So, to understand kinematics, we have to first understand what is rest and what is motion. So, to study rest and motion, first we have to know frame of reference. Frame of reference means a coordinate system from which we can measure the position of a particle. So, if a body doesn't change its position with respect to time, with respect to a frame of reference, then that is called a rest. So, a body is said to be at rest if it doesn't change its position with time with respect to a frame of reference. That means we can say if a body is at rest with respect to one frame, it can be in motion with respect to another frame. For example, consider a passenger sitting in a bus. Now, the bag of the passenger is at rest with respect to the bus, but the bag of the person is in motion with respect to a person standing outside. So, there is no concept of absolute rest or absolute motion, because a body can be at rest for one frame as well as it can be in motion with respect to another frame. Then, we'll go for what is motion. If a body changes its position with time with respect to a frame of reference, then body is said to be in motion. So, a body is in rest with respect to one frame, can be in motion with respect to another frame. So, rest and motion are relative concepts. So, we can say a body is at relative rest with respect to a frame or relative motion with respect to a frame. It can, so rest and motion cannot be absolute, because all the frames in this universe are themselves moving. So there is no concept of absolute rest or absolute motion. Then we have two types of frames of reference. One is called inertial frame of reference. Second one is called non-inertial frame of reference. So, inertial frame of reference means the frame of reference has no acceleration. So, the frame is moving with a constant velocity. Then that frame of reference is called inertial frame of reference. Now, if the frame of reference has acceleration, then this is called non-inertial frame of reference. Here the velocity of the frame may increases or decreases. Now, all the laws of physics are valid in inertial frame of reference. For non-inertial frame of reference, we have to add a pseudo force. That part we will study in the laws of motion. Now, in this chapter, we will consider only for inertial frames of reference. Then, we will go for distance and displacement. So, distance is the actual path traveled by a body. Consider a body moves from A to B. So, it can move along the path 1, it can move along the path 2, it can move along the path 3. So, the actual path length covered by a body is called distance, but the shortest path between initial and final position is called displacement. Now, in any way, if the body moves from A to B along path 1 or path 2 or path 3, the displacement will be a B vector, but the distance will be the actual path length covered by the body. So we can say distance is a scalar quantity while displacement is a vector quantity. If the initial and final positions are fixed, the distance is not unique, but displacement is always unique, because if a body travels from A to B, then if for any path the displacement will be a B vector, but the distance will be, if it moves in path P1, then it is this length. If it moves in path 2, then you have to measure this length. Now, distance can never decrease with time. It always increases and it remains constant when the body is at rest. So, if distance remains constant, then we can say body is at rest. But displacement may increase, decrease, or remains constant. Next thing, distance is always positive. Displacement can be positive, negative, or zero. If a body is in motion, distance can never be zero. It is always positive. But displacement can be positive, negative or zero. The next part. The magnitude of displacement is always less than or equal to distance. So we can say distance is always greater than or equal to magnitude of displacement. So the equality holds good if the body moves in a straight line. So we can say distance equal to magnitude of displacement when the body moves along a straight line. If the body doesn't move in a straight line, that means it moves in a curved path, then distance is greater than magnitude of displacement. The last part is distance depends upon frame of reference, while displacement is independent of frame of reference. Distance depends upon frame of reference, but displacement is independent of choice of coordinate system. So this is the basic difference between distance and displacement. Next, we will go for speed and velocity. So speed means distance by time. Velocity means displacement by time. So the distance covered in unit time is called speed. The displacement in unit time is called velocity. So we can write it as s by t. This is equal to s vector by t. So as distance is a scalar, speed is also a scalar. But velocity is a vector. So as distance is always positive, speed is also always positive. Velocity may be positive, negative or zero. If a body is in motion, for motion of a body, speed cannot be zero, but velocity can be zero. For example, if you throw a ball upward, at the highest point its velocity becomes zero, but its speed is non-zero. Then we can say speed depends upon frame of reference. Next part is, we'll go for average speed and average velocity. Average speed and average velocity. V average speed equal to total distance by total time, and average velocity equal to total displacement by total time. Now, how we can calculate this average speed and average velocity? Now consider a particle is moving along a straight line. So in this case, speed and velocity are same. So let it covers s1 distance in time t1. So its speed will be s1 by t1. Let it covers s2 distance in time t2. So its speed will be s2 by t2. Now, it covers S3 displacement in time T3. Like that, it covers Sn distance in time Tn. Now, its average speed will be S1 plus S2 plus S3 up to Sn divided by T1 plus T2 plus T3 up to Tn. So, next, consider a body moves S1 distance with a speed V1. So, time T1 will be S1 by V1. Now, it covers S2 distance with speed V2. So, time T2 will be S2 by V2. And similarly, it covers Sn distance with speed Vn. So, time Tn will be Sn by Vn. So, the average speed will be S1 plus S2 plus S3 up to Sn divided by T1 plus T2 plus T3 up to Tn. So, we can write it will be S1 plus S2 plus S3 up to Sn divided by S1 by V1 plus S2 by V2 plus S3 by V3 up to Sn by Vn. Now consider the particle covers equal distances with different speeds. So fastest distance it moves with a speed V1, next distance with a speed V2, like that the nth distance with a speed Vn. Now its average speed will be here S1, S2, S3 up to Sn all are equal to S. So the numerator will be Ns. Now taking S common from the denominator, we can write 1 by V1 plus 1 by V2 plus 1 by V3 up to 1 by Vn. Now V average equal to n by 1 by V1 plus 1 by V2 plus 1 by V3 up to 1 by Vn. This is called harmonic mean of each speed. So, if a particle covers equal distances with unequal speeds, then its average speed will be the harmonic mean of all speeds. Now, we can write it as n by V average equal to 1 by V1 plus 1 by V2 plus 1 by V3 up to 1 by Vn. Now consider a special case. If a particle covers first s distance with speed V1 and next s distance with speed V2. A particle covers first half distance with speed V1 and the next half distance with speed V2. Then the average speed is given by, we can write n by V average, that is equal to 2 by V average equal to 1 by V1 plus 1 by V2. That is equal to V1 plus V2 by V1 V2. So V average will be 2 V1 V2 by V1 plus V2. Now consider another case. A particle covers first 1/3 distance with speed V1, the next 1/3 distance with speed V2 and the last 1/3 distance with speed V3. Then the average speed, we can write 3 by V average equal to 1 by V1 plus 1 by V2 plus 1 by V3, which is equal to V1 V2 V3, V1 V2 plus V2 V3 plus V3 V1. So V average will be 3 V1 V2 V3 divided by V1 V2 plus V2 V3 plus V3 V1. So now We'll go for the next case. Consider a particle is moving with speed v1 for time t1, with speed v2 for time t2, with speed v3 for time t3, and like that with speed vn for time tn. Now in time t1 it will cover a distance equal to v1 t1, like that s2 will be equal to v2 t2, s3 will be equal to v3 t3, like that sn will be equal to vn tn. Now the average speed will be s1 plus s2 plus s3 up to sn divided by t1 plus t2 plus t3 up to tn. So we can write it will be v1 t1 plus v2 t2 plus v3 t3 up to vn tn divided by t1 plus t2 plus t3 up to tn. Now if the particle moves with speed v1 for time t, v2 for time t, like that up to vn for time t. That means the particle or the object moves with different speeds for equal intervals of time. Then the v average will be, so it will be v1t plus v2t plus v3t up to vnt. Taking t common, it will be v1 plus v2 plus v3 up to vn, and t plus t plus t n times, that is equal to nt. So it becomes v1 plus v2 plus v3 up to vn divided by n. We can say this is the arithmetic mean. So if a body moves different speeds for equal intervals of time, its average speed will be the arithmetic mean of all speeds. Now let a particle covers first half distance with v1, for first half time with speed v1 and the next half time with speed v2. Then its average speed will be v1 plus v2 by 2. Now let the particle moves for t time with speed v1, next t time with speed v2, and the last t time with speed v3. Then its average speed will be v1 plus v2 plus v3 divided by 3. Now consider a question. Let a particle moves with speed v1 for first half distance. In the next half distance, it moves with speed v2 for time t and v3 for time t. So what will be its average speed? Now in this interval, the particle is moving with different speeds for equal time. So here in this interval, the average speed v23 equal to v2 plus v3 by 2. Now we can make this question as a particle moves for s distance with speed v1 and the next s distance with speed v23. Now the average speed will be 2v1 v23 divided by v1 plus v23. So which becomes 2 into v1 into v2 plus v3 by 2 divided by v1 plus v2 plus v3 by 2. It becomes 2v1 times v2 plus v3 divided by 2v1 plus v2 plus v3. Now if we change the question, Let the particle moves for first half time with the speed v1. For next half time, it covers first s distance with speed v2 and next half distance with speed v3. Now the average speed in this time will be v23 equal to 2v2 v3 divided by v2 plus v3. Now the total average will be v1 plus v23 by 2. That is equal to v1 plus 2v2 v3 divided by v2 plus v3 by 2, which will become v1 v2 plus v1 v3 plus 2v2 v3 divided by 2 into v2 plus v3. This will be the average speed. So in this class we have gone through the concept of average speed and average velocity. Carefully go through the problems. If any doubt arises, ask in the telegram given in the link.